and in this video we'll demonstrate the basics of how to use gas detection tubes and hand pumps to measure a specified gas in air or another matrix gas such as natural gas. First, I'll demonstrate an overview of how the gas detection tubes work. The tubes contain a chemical reagent that changes color when a particular compound in the gas sample is present. The hand pump pulls a fixed volume of air into the tube. Let me demonstrate. The piston pump pulls 100 cc's, and you can see the tube changing color as the water vapor is being absorbed into the chemical reagent on the tube. At the end of the sampling time, the stain length stops and the concentration is read from the length of stain. In this case, the stain seems to be ending at around 10 milligrams per liter. Here's a schematic diagram of the tube. In this case, we're measuring hydrogen cyanide, or HCN. The tube before exposure is this light yellow color, and you can see on exposure to hydrogen cyanide, the stain has turned a bright red color. The concentration is read from the scale printed on the tube. In this case, it's reached about 25 parts per million. Also written on the tube are the direction of flow arrow, showing the direction the gas should be flowing, the tube part number, the tube code, and the sample volume, which is 200 milliliters or 200 cc's, which equals 2 pump strokes. Here's how the hand pump works. The hand pump has a piston and barrel design that holds a strong vacuum. The piston locks in place at 100 cc's. Without a tube in the inlet, the chamber fills quickly. With the tube in the inlet, it takes about a minute or two for the chamber to fill because of flow resistance within the tube, which controls the flow. Note that the pump has a few special features. The rubber inlet is designed to accommodate tubes of different diameters and still make a good seal. On the head of the pump is a tube tip breaker used to open the glass tubes, as such. The tips are collected in a reservoir which can be emptied as it's filled up by using the rubber cap on the other side. The pump also has a vacuum test indicator. When a vacuum is pulled on the pump, the indicator moves down and then gradually returns to the starting position as the gas goes through the tube. The hand pump can lock in place at either the 100 cc position, which we call one full stroke, or half a stroke position for sampling 50 cc's. To sample, align the red dots on the pump and the shaft by rotating the pump handle, and then pull all the way to the end, and it will lock in at 100 cc's. For a second stroke, rotate the handle 90 degrees, push it back in, and line the dots up again and pull out again. To do 50 cc's or half a stroke, start at the starting position, pull just past the 50 cc position, and let the pump lock in at the 50 cc position for a half stroke. Before starting a series of measurements, you should know the sample gas volume, the time required for sampling, and perform a leak check. The sample volume and time are given on the outside of the box. Here, sample volume and the time, and on the tube sheet that's enclosed in each box. The standard range here showing 2 pump strokes for 200 cc's, and each stroke takes 1.5 minutes for a total of 3 minutes for sampling. To determine the end of sampling time, you can either use your wristwatch to just keep track of the time, or if it's easier, just follow the vacuum test indicator to show when the pump indicator has returned to the original position, indicating that the flow is complete. Before each set of measurements or each day's measurements, it's very important to perform a leak check to make sure that the pump is working properly and the tubes fit in the inlet correctly. To perform a leak check, insert an unopened tube into the inlet. It must be an unopened tube. Then align the dots, pull one full stroke, and use your stopwatch to measure for 2 minutes. At the end of the 2-minute period, carefully rotate the handle, keeping some resistance on the handle with your fingers so that it doesn't snap back quickly, and allow the pump piston to be drawn back into the pump as such. The pump, if it has a good vacuum seal, should return to the original red line and to indicate that there is no vacuum loss and the pump is ready for use. As we said, it's important to do a leak check before each day's measurements, but it's also important to do a leak check when you're changing from different types of tubes, especially tubes of different diameters, because the seal on the inlet may vary in integrity depending on the diameter of the tube. The sampling volume is also indicated on the end of each tube. In this case, 200 milliliters or 200 cc's for 2 strokes. With this tube, it's 100 milliliters or 100 cc's for 1 stroke. And in this tube, it's 50 cc's or 50 milliliters for 1/2 stroke. Now that we've performed a leak check, we're ready to make an actual measurement. In this case, we use a water vapor tube to measure ambient humidity in the air. We check the tube sheet, which shows that this tube takes 100 cc's or 1 full stroke, and the sampling time required is 1 minute. To make the measurement, first break open the tube using the tube tip breaker. When breaking the tube open, don't hold it too far away or it may break in the middle and cut yourself. Hold it close to the tube tip breaker. When that's complete, look for the flow direction arrow and insert that end of the tube into the pump so that the flow goes towards the pump. Hold the tube close to the inlet rather than far away, once again, so that the tube does not break accidentally in your wrist. Hold the tube out into the sample gas, align the red dots, pull the pump out for 100 cc's, let it lock, and wait for the sampling time of 1 minute, or check the vacuum test indicator to follow the end of the flow to it. Remove the tube carefully from the pump and read the stain length. In this case, we have a concentration of about 10 milligrams per liter. If the stain is slanted, take the average of the longest and shortest points. It is best to read the tubes immediately after making the measurements. Although most tubes have a stable stain and will remain that way for hours or days, some tubes will diffuse or disperse, or in this case water vapor will keep entering the tube and give a longer stain with time. Therefore, again, make the measurement immediately after taking the sample gas through the tube. So finally, check the tube sheet for any cross-sensitive compounds that may have affected the reading of the tube. We can see here on this table that all of these compounds have been tested for cross-sensitivity on this tube, which happens to be the HCl tube, hydrogen chloride. And when all these concentrations were applied, all the tubes gave a 0 response. In other words, no cross-sensitivity, except for chlorine. Chlorine gas gave a significant response. Therefore, if chlorine is present along with hydrogen chloride in the gas sample, there will be an interference and it will detect both chemicals. Note also that the color change of the tube when it's been exposed is the same or very similar to the color change indicated on the tube sheet. If this is not the case, if the stain is smeared or it's a different color, that gives an indication that there is some interfering compound present. Some tubes use a pre-tube in front of the measurement tube to precondition the gas. Pre-tubes are used for such things as drying the gas, removing chemical interferences, or to convert the target compound into a form that is measurable in the measurement tube. To use a tube, first break open all four ends of both tubes, and then insert the ends with the two X's into the rubber connector. Then, making sure the arrow is pointing towards the pump, insert the measurement tube into the hand pump. The gas flow should be such that it enters the pre-tube first, then goes through the measurement tube and into the hand pump. When finished, be sure to dispose of tubes in a safe and environmentally friendly manner. The sharp ends of the broken tubes can cause cuts if not handled carefully. Most tubes contain such small quantities of chemicals that if you have only a few tubes, they can be disposed of in the regular trash. However, large quantities, or those with toxic or corrosive chemicals, may need to be treated as hazardous waste. The tube sheet lists any active ingredients that might be hazardous, in this case lead acetate.